Saxon Algebra 1, Lesson 29. This is a great, to-the-point algebra lesson, students. Two crisp, clean rules, both about exponents. The first one is about negative exponents. If you take any number or letter and you give it a negative exponent, okay, I'm using X to stand for any letter or number, and I'm using N to stand for any number. Notice there's a minus sign, not in front of the base, but in front of the exponent. What that does is it acts as a little trapeze bar, and it flips the base and the exponent itself down to the denominator. You've probably seen trapeze artists in circus settings where one person's swinging on a bar and another person's swinging on a bar, and somebody lets go and they flip in the air and then they catch to the hands of the person on the other trapeze bar. So they used to be on the top and now they've let go and they're caught by someone else, so they're like in the bottom. That's what I always think of. Notice that the base stays the same, the exponent number stays the same, but the minus sign gets burned up. It gets burned up in the flip, right? And so it is not down here. It goes away, all right? This is a minus sign that behaves very differently than minus signs out here. This guy is just a trapeze artist, and that's all we have to do is recognize that about him. So this is our rule. And just to help us in similar but slightly different situations, if we're starting with a negative exponent in the bottom, then that flips up. Okay, so the trapeze can work from the bottom to the top, and that would be, you know, this guy swinging along on the trapeze of this other dude, and then he flips back and catches his own bar again. Either way, we can make it work. So let's practice this in a handful of examples. 29.1, simplify 3 to the minus 2. Okay, remember it has nothing to do with the minuses out here and the squaring. No. It has nothing to do with that. Although later we're going to factor it in and we're just going to make ourselves crazy. This simply means flip. So the base goes down and the number of the exponent goes down, but now the minus sign has been burned off. And then we just simplify this 1 over 9. Yay, final answer. Let's try another. This one is this style. 1 over 3 to the minus 3. Okay, so we see the trapeze works in the same way. If it's in the bottom, then we flip up to the top. So this becomes 3, the base stays the same, the exponent stays the same. We just burn off the minus sign as we flip it. 3 cubed is 27, so that's the final answer there. See, they're super straightforward. Of course, we're going to combine it with a million other things, so never mind. It's not going to feel straightforward for long, but that's okay. That's math on the fast lane, right? In the third one, we're saying, okay, let's put a minus sign in front of the base as well. Okay, here is my best advice to you. On that first flip of the trapeze, leave everything else exactly the way it is, all right? So I see this, I go, okay, it's gonna flip down. I don't worry about fixing anything else. I just copy the base exactly the same and the exponent the same, except the minus sign is burned off. First, just copy it and take care of that negative exponent. We always do those first. Now I see, okay, this is -3 times -3, right? I can't cover that up. So as I square that, it becomes an old familiar kind of problem, and that's my final answer. And then let's squeeze one more down at the end. 29.4. Oh, of course it's more complicated. okay? What we can do with these is we see all of the bases are written up here together. And we could bring these down to the bottom and simplify them. But what we can also do is simply add the bases, which is what we've been doing, right? So we would say x to the fourth plus minus 2 gives us x squared, right? Instead of flipping these trapezes, we're just combining them using our product rule for exponents, right? Which is that if you have matching bases and different exponents, you add the bases. So we're adding 4 and minus 2 to get positive 2. And then let's do the m's. We're adding 2 and negative 5, so that's negative 3. So this can be our answer. But we can also write it with all positive exponents. We can also write our answer as x squared, and then we can trapeze this down to the bottom, m over 3. So this is another way to write the same answer. They are equal and they are equally desirable. Like distribution, negative exponents are neither right nor wrong. Usually we want to simplify them, but once we get our answer simplified, it doesn't matter if there's a negative exponent or not. Oftentimes John will tell us, simplify with all exponents positive, or simplify with all exponents in the numerator. We'll talk more about that as we go, but each of these are equally desirable answers. This one just has a negative exponent, and in here we trapezed it down to the bottom. All right? So it's not right or wrong, it's just different. We have one more example before we switch to our other topic. Simplify. Oh, the chain's getting even longer, so I'm going to spread this out a little bit. Remember, those are my Z's. I know they look weird. Okay, I'm just double checking. All right. I see that I've got the same bases repeating over and over. I've got X's, Y's, and Z's, right? And I'm going to be combining those. I know that when I combine, I add the exponents, right? I just talked about that on the last page. That's called our product rule for exponents. We'll be doing this so I don't have to take care of these negative exponents right away if I don't want to. I can just leave them and add them as negative numbers. I am going to want to put ones on these exponents that don't have a number. Okay, so let's go through and add up all the exponents on the x terms. I have a minus 2, and then I have a plus 4 and a plus 1. That equals, let's see, this is 6 minus 2, so that would be, no, that's 5. Minus 2 would be 3. And then on my y terms, I've got a minus 6 and a plus 5. That's all. So that becomes a minus 1. And on my z terms, I've got a 1 and a 5. Both positive, and that equals 6. So I can write my final answer as x to the third, y to the minus 1, z to the 6th. That is a perfectly lovely answer. If we wanted to write it with all of the exponents positives, then we leave the 3 as it is and the z as it is, but we would trapeze this y down to the bottom. And because now it's just a positive one, I can take that. I don't have to write that one. I can just write it like this. We need the 1 here because we have to put a minus sign in front of it. All right, so these are equally good answers. All right, the second topic of this lesson has to do with 0 exponents. And this is just a simple rule that you can memorize. Any base that you raise to the 0 power is equal to 1. That's it. If you raise something to the 0 power, it equals 1. That feels a little random. We're not going to get into the theory of why that's so because I don't want to confuse you. Just trust it as a simple rule. Now, I want to just lay it alongside of this other rule because students often get them confused. If we raise any base to the power of 1, it is that base again. But when we raise something to the 0 power, it just wipes the base away and it's just reset to a 1, all right? So make sure that you understand this rule. Excuse me, yawn break. Go ahead and yawn. This rule is different than this rule, and it helps to lay them alongside of each other so you can see the difference. X to the power of 1 is just that base. X to the power of 0, the base gets wiped and it's just a 1. Okay, these are fun because when you run into them in problems, it just wipes things out, and that's usually a happy moment. I mean, you know. Okay. We have 4 more examples and then we're done. Oh, Grace is lying with her head on my foot and it's so comfy. 29.6. Simplify the following expressions. Oh, John's going to cheat and give us an A and a B. It doesn't seem fair, does it? But, you know, his book, his rules, right? A. Here we go. X squared, y to the 5th, okay, so there we see we have 2 x's and 2 y's, so let's simplify them, the exponents. We're going to use our product rule once again. I'm following my rule of making sure that I have my formulas on every page that I need them. And I'm also going to remind myself of this. X to the 0 equals 1. Okay, with x, we've got a positive 2 and a minus 2. Aha, that equals 0. What that tells us then is that our x term is going to disappear. And I'll show you that in another way in just a second. Okay, our y term, we have 5 and minus 2. That equals 3. So our final answer, you could write it as x to the 0, y to the 3rd, but we don't even need to show that term. We just write y to the 3rd, and that's our final answer. Yay! Okay, so when you calculate a new exponent for a base is equal to 0, then that base just gets wiped out. It's gone. We don't need it anymore. That's always a joyful moment in a math problem. Okay, here comes another one. Okay, so we have a 4-part expression. 2 of the bases repeat. We know we can add the exponents. So for m, I'm going to do 5, and then this one needs an exponent, plus 1. That equals 6. And then for b, we have 2 and minus 2. Aha, so that equals 0. Our final answer then, the b is wiped out, and we just have m to the 6 as our final answer. And P.S., when you're doing your homework, if you're going through and making you're adding your exponents together, and you see oh look, my b's are gonna wipe each other out and we're gonna get to 0 and it'll go to 1 and it'll disappear. You don't even have to write this out. I'm doing it just to make sure you understand. But feel free to notice that and go, shoot, I don't even have to write it down. Example 29.7 looks like this. I'm getting a little squeezy down here at the end. Okay, so what we have is a distribution situation. We've got this term times the quantity this term minus this term. And we've got positive and negative exponents going on. And we even see a couple 0 exponents going on. So what we can do right at the very beginning is we can just cross out the terms with the 0 exponents. We don't need them at all. We can simply whack them out. I'm going to put ones on, I guess it's just this one term that doesn't have them. And now we can distribute, but it's perfectly safe to wipe these out right from the very beginning. Okay, we're multiplying. That means we'll be adding the exponents. So I'm going to go in alphabetical order. I'm multiplying x, z times p. So I'm going to do p first because that's alphabetical. P to the minus 3, x to the 5th, and then z to the 1st. I'll leave that exponent off. Minus, because that minus sign, 4. We're multiplying this 4 by an invisible 1, so it stays just the same. Now let's do the x's. Oh, x is plus 5 and minus 5. Oh, that goes to 0. And it can be we can just cross off the x. There isn't going to be an x term in the second part. And then z to the 1 times z to the minus 1. So the z's cancel as well. So our final answer just looks like this. P to the minus 3, x to the 5th, z minus 4. And that is because I'm going to write it again, just so we have it right here. And once we set things to 0, the 1 can disappear, right? So that's why we could just cross those out, because once they're raised to the 0 power, they're equal to 1, and poof, they're gone. Hit with magic pixie dust that makes them disappear. So this is our final answer. Notice that we have a negative exponent in our numerator. It's fine. If we wanted to flip it down, we could. But again, negative exponents are neither right nor wrong. And once we have simplified as best we can, it's okay to leave them. Okay, a couple more of these problems. And then we shall be done. 29.7. Grace's head is still on my foot, so I can't really move. So I might as well just sit here doing problems all day long. 29.7, use distributive oh no, we just did that one. Yeah, we did 7. I was gonna say, that looks so familiar. It's because I just did it. Okay, 8, use the distributive property to expand. Okay, so it's the same kind of problem. But I don't see any zeros in the beginning. We'll see what happens. If you listen carefully, you might hear Grace snoring. Okay. So we're distributing. I didn't draw it last time, but we can always draw these. Okay. We see there's matching bases. We see there's some negatives and some positives, so we'll just be adding those together. Again, we're using our product rule to remind us that whenever we're multiplying matching bases, we can add the exponents. So let's start with these two. We'll go alphabetically. X minus 2 plus 2. Uh-oh. X to the 0, it's gone, right? So we don't even have to write it down. And y to the minus 2 plus 2, that's y to the 0. Okay, I'm going to write this down just so you can see it. Right? That's what we got for this first multiplication. Let's just go ahead and do the second multiplication before I fix this. Okay, for the second one, we'll have plus, that's that plus sign, that's the 4 multiplied by the invisible 1 there. X minus 2 plus 4 is positive 2. And y minus 2 plus 2 is 0. Okay, so we got 3 zeros when we did that. Now, how do we clean this up? Well, let me remind you of one more thing. When we raise something to the 0 power, it's equal to 1. It's not equal to 0, it's equal to 1. So when we have this, we actually have 1 times 1. So we can simplify that by saying 1 plus 4x squared, and then this, we don't need to write the 1 because we've already got a placeholder for that term. Here we have to create a placeholder for this term by writing the 1. Down here, the 1 is being multiplied by this, so we don't have to write it separately. That's a fine point, but it's an important point. Okay, remember that if your term completely disappears, it's turning into a 1, not a 0. And the last one. This one is 3 simpler problems. Or smaller, I shouldn't say simpler, because they aren't necessarily simpler. 2 to the 0 power. B, oh, these are good. Because what we're discovering here, what we're playing around with is how do minus signs affect this calculation? Okay, 2 to the 0 power, that's just like this. We know it's equal to 1. Okay, with this one, we can cover up the minus sign. 2 to the 0 power is 1, but now we take our finger off and there's a minus sign. Okay, but in this case, we can't get in and cover up that minus sign. It's protected. So there's nothing we can do to say that. So this whole expression is raised to the 0 power, and that means it's a positive 1. Okay, so if we can cover up the exponent, or the minus sign, I'm sorry. If we can cover up the minus sign, then the minus sign lives on, and we tack it onto the answer. But in this case, we can't protect the minus sign, so the minus sign is part of the base that gets turned into a 1, and our answer is positive. This is tricky, this is sneaky. Put this deep into your brain so that when you run into this problem in bigger problems, you'll be able to make the distinction, right? It's all about, can you cover that up? If so, then it's protected and you add it on at the end. But this one you can't cover up, so it just gets exploded in the process of turning the base into a 1. It gets demolished in that process. Okay, guess what? Lesson 29 has come to an end. I'm really sorry. I hope you enjoyed it as much as I did, and I will see you next time.